Alright, it's been a while since the last video. Frankly, I moved from Spain to here, and since my parents moved houses, and I had to help them out, sorting out things and carrying things. Um, and also, my sister has given up birth to a new my nephew, so everything was kind of messy and didn't have a chance to record. Actually, I was actually solving some problems, but I couldn't record myself. So this video, probably this video and the next video will be recording after I just coded everything. Okay. So I share my screen. I solve this problem. First unique character. This program at LeetCode is basically you're going to be giving a string and find the first non-repeating character in it and return its index. And if it does not exist, return -1. So that is a big picture of the problem. And again, I already solved the problem, did step 1, step 2, step 3 already. So I'm thinking what to do with this video. Probably I'm going to revise what I did, what I thought at some point, and how I fixed it, how I designed a solution along with the timeline. So this is the memo. Yeah, this is just problem description at the top. Step 1. Oh yeah. So okay, let me see the code, first code, and I'm making it bigger for you. How can I make it bigger? All right. I think it's kind of easy to see the code with this with this size of the phone. Um, so what I thought was to create an array that's name is occurrences and whose length is the same as the given strength. Okay, and I also create a mapping between character and its index, but this index will only store the first occurrence. If the same character appears twice or three times in the string, it will only record the first occurrence of index. So if the first, let's say, the letter S appears at the index of 5, then it will record 5 along with the key of S. And the second appearance, let's say, appeared on at the index of 10, it does not save in this dictionary, it just ignores. Okay, and then we're going to loop over the string, over the letters in the strings, and get the character. What's the character of index 0, 1, 2, 3, go over iteratively. And if the character exists in the mapping, okay, then you get the index. Yeah, it's the first occurrence, and you will add 1 to the occurrence. So occurrences array will represent how many times that a certain certain character occurs in the given array. But because we are going to refer to a mapping that only gives the first occurrence, it will record. Um, so like I said, if the character of S occurs at index of 5 and 10, it will record the occurrence at the index of 5. That's the first occurrence. So it will now record to the index of 10. Index 10 will remain 0 as initialized at the beginning, but we will increment the value that corresponds to the first occurrence in the given string input. Okay, so that's what it does when character exists in the mapping. If not, then we need to create a mapping, right? So if not, that means it's the first occurrence. So we're going to create a mapping between the character and its index in the mapping, and then set the occurrence at the index, at the current index as 1. I mean, you can actually put uh, plus equal 1 like this. I cannot edit. Alright, I need to open file to write. Yeah, I think it will work as this one. Let me just confirm. Alright. Let me just confirm this works, okay? Yeah, of course, of course. So yeah, maybe this this way is much, I mean, slightly better. I'm not sure, but anyways, it does exactly the same. So if the code goes to here, then it means it's the first occurrence, so it makes sense as um, asserting 1 into this, but at the same time um, adding 1 into the current value also works. So whichever you want. I personally wrote the code in this way, but either is fine. And then after this loop, you're going to iterate through the occurrences array and search for the first item that equals to 1, and that is the unique. Okay, so that is the first unique character in the given array, and return its index. And if it goes out of the loop scope, it means there were no such item in the occurrence array that's occurrence only happens once. So that means there were no item in the occurrence that's unique. We return -1. Does that make sense? I hope that makes sense. That's how I solve the problem at step 1. And as for step 2, what I did, okay, so after solving this problem, I wanted to see how other people solve this problem, and one solution hit me really hard and impressed me, inspired me. I wanted to solve my problem in this way, so I changed a little bit of my coordination. So this uses last recently used cache. So what it does is like a variation of LRU cache mechanism. So what it does, okay, so from the very big picture, you have the solution class, and there you go, the the method to solve the question, the problem, and you initialize a tracker. This is unique character tracker that tracks unique character in order. And just a quick context, it will hold a linked list of unique character. Yeah, in order. So you go through each character in the given string, and you're going to keep putting the character along with its index to the tracker. And after the loop, you will have the tracker tracking all the unique elements, characters, I mean, in the string in order of occurrence. Okay? So you're going to see the first node basically and return it. So let me ignore it first. I explained this part. So the tracker has internal node linked tree, and you're going to see the first node Head node is a dummy node, so you're going to see the next to the head node, which is the first node, actual node, and it has a information. It has index data, so you're going to return this one. And if tracker is empty, so there are nodes on at the beginning and at the end. So there are two nodes representing just dummy, and there's nothing in between. That means there's no unique character in the given array, given string. So we return -1. Does that make sense? So that's a overall like very big picture, high level explanation. And what's doing inside? Let me just explain it. So this is just a data class that represents node. It has index. That's what we need to return at the end of the process. So we need this data. We additionally can include count to keep track of the occurrence, but it's not necessary to solve this problem, but you can do it. So prev node, we have next node to form a linked list, and it's just the initializer. So you give index a value, and it will set the internal state as well as internal state of the index prev next. Okay. So unique character tracker contains head and tail, both initialized as -1 value of node. Okay. And head next to the head goes to tail, and previous of tail goes to the head. Okay, so that's how we form the initial linked tree. Okay, and additionally we have chart to node. This so this maps character to node. Okay, so each character has its own node, and we keep track of the relationship between them throughout the process. So we have put method, as we saw earlier. We keep putting character and its index, and we going to search the character in the chart node dictionary, and if it exists, then it means that we have already created a node for the character. So we get the node, and if the character exists, that means that character already occurs more than twice. Okay, no, I mean more than once. Okay, so it's the second time, or three times, or whatever. So we basically want to remove the node, that corresponding node, from the inner linked tree. Okay, so we do that here, and I will explain what exactly it does later, but it's just it. Okay, it's just it. Okay, and if that doesn't exist, that means it's the first occurrence. So we want to create a new node for that particular character, along with index, of course. To initialize node, we need to pass index, so that's why we pass index as a parameter of the input method, put method, and then put the node into the linked tree. The method is called append, which I will explain later. And then you need to create a mapping between the character and the node in the dictionary. Okay, I hope that makes sense. It's super simple. And let me explain remove or do nothing method. So let me explain from here, okay, rather than this part. It's kind of hard to understand at the first sight without explaining this part first. So if you want to remove a node from linked tree, what you want to do is to get the previous node of that node that you want to remove, and the next node, and you're going to make um, the previous node to refer at the next node, not that node that you want to remove, because currently it refers to the node. So you want to replace the relationship from the node to the next node of the current node that you want to remove. You know what I mean? And then same likewise. So for the next node of that current node, it refers to the current node when you refer to the prev data point here at this at the node data structure. So you want to refer it back to the previous node from the current node. Okay. And also you want to set none both to next and prev data point at the current node, because you want to basically remove from the link tree, so it should have no connection to any of the node. So that's what happens if you call this method the second time it occurred, the character occurred. But from the third time, you will be giving a node that has no relationship whatsoever. So you want to do nothing. Like there's absolutely nothing you can do. So if node next is none and node prev is none, that means it's already removed from the linked tree, linked list. I've been saying linked tree, but it's not linked tree. It's linked list. Um, so if it's already removed, you do nothing. Okay, so that's what it does in this method. Here append. So if it's the first occurrence, you want to call this method to append the element in the linked list. So you give node, and you basically want to put the node right before the dummy node of tail in the tail. So you get the previous node from the tail and make it refer to the current node that you pass in, and the current node should refer to the tail, and tail should refer back to the tail, back to the current node, and the current node should refer back to the previous node that was originally, before calling this method, placed right before the tail. Does that make sense? So that is what it does in this method. Okay. And yeah, after going through all the characters in a string, I am calling this method is empty to verify if the linked list is empty or not. And in order to check that, you're going to see head next index equals -1. So if it's equals -1, that means there's nothing in between head and tail, because -1 is only possible for head and tail. Okay, so that is a concrete and in detail explanation um, of this solution. So I hope that makes sense. So that's basically how we did. Step 3 is just a practice for coding in less than 10 minutes. So basically the same with a minor change, because next we have we have next method. So it's kind of misleading. I wanted to be clear. I wanted my code to be clear without any room for misleading. So I named this data point as pref node and next node. This is just a minor change, minor refactor. So I'm not going to repeat all the explanation that I just gave you. So basically that's it, okay? And I need to, all right, let me slightly modify this memo. I didn't keep all the things that I just said. Take a look at another solution. Alternatively, you can locate tracking characters on PC. I thought okay. Made a slight change. Renaming pref and next on node structure to pref node and next node respectively. This is because in Python we have the function for iterator called next, which might confuse the code reader. Alright, that's enough. Additionally, I want to ask Claude to read this memo and translate it to Japanese, because the reviewers is going to be Japanese software engineers. So I want to create put a Japanese translation at the top of the file. Translation of the entire file at the top of the file. I hope it does its thing correctly. Last time I did was a bit messy. I'm going to allow auto accept. Alright, let's wait. Yeah, alongside I'm recording this, I'm cooking my lunch, so I'm going to finish this recording and then get back to my how do you say, my cooking. I'm so starving right now. Alright, but I guess I explained everything that's required for you guys. Yeah, I explained the method, solution, and how I solve it. Yeah, so I'll see you in the next video. The next video will be about zigzag conversion. Yeah, so I hope I'll see you soon. Probably indeed will be recording the video very soon after the lunch. So have a nice day. Bye bye.